Now that we know where our water is located, how we use our water, and then also why we should save our water, we're now going to look at where our water comes from. And the majority of the water that we use comes from groundwater. So, and if you have well water, then that is you getting your water from groundwater. So half of the water used today comes from groundwater. So most of the public, or half of the public, they're actually getting their water not from a river, from a lake, but from groundwater, which means using wells. A lot of times, if you live outside the city limits, you probably have ground or well water. But there can be whole cities that also get water from large aquifers, which we still consider groundwater. Places like Mexico City, they live on top of a very large aquifer where water can be pulled from. So half of everywhere comes from the ground. Now, there is a video down here at the bottom. If you'd like to look at later, you can. It's just a video of some people digging a well by hand. Nowadays, we use machines to dig wells, which you could also look that up. But if you are interested in what it looks like to actually dig a well by hand, then you could look at that link down there below. So how does water get into the ground in the first place in order for us to use it? Well, this is one of those words that we looked at earlier, infiltration. So water gets into the ground through infiltration, or infiltrating through those spaces. And remember, the way that it moves through those spaces is what we call percolation. So infiltration, just getting into the ground, percolating the way it's moving into the ground. So when it rains, some of that water will evaporate, some will just flow off or run off and collect in other bodies of water. But the water that doesn't evaporate or run off, it infiltrates. So how much water goes into the ground will depend on a few things. One is the steepness of the land. If you have a big hill or a mountain, you're going to have more infiltration down at the bottom of the hill rather than the top, because all that water is going to run off down to the bottom where it then can infiltrate. Then also the surface materials. If your ground is made out of soil, you will have a lot more infiltration than if the ground is made of rock. There also are areas such as urban areas that have a lot of roads. And if you have a lot of roads and pavements, then you're not going to be able to have as much infiltration. You'll get more runoff and just collection of pollution, actually, that will collect there. And then also vegetation. So having vegetation, just looking at your plants, plants help to absorb water because they use up some of the water, allowing more to get into the ground. But plants can also help slow down the rate water gets to the ground, which can help water to be able to infiltrate easier because it doesn't pile up and flood instead. So as water goes into the ground, it creates 3 different zones. The first zone we're going to look at is the zone of saturation. So imagine it's rain. You're a little drop of rain, and you hit the ground, and you're going to go down into the ground, infiltrate, until you get to a place where you can't go any further, and then the water will collect and build up. That's what we call the zone of saturation, meaning it's completely filled and saturated. There, all the little small spaces in the dirt can't hold any more water. So this is where our groundwater is, and this is where you would dig a well. So if you were going to dig a well, it would come up from this zone of saturation and go to the top. The next slide will show you these 2 other zones, but with the same picture. So we already looked at our zone of saturation. Right above the zone of saturation is your water table. The water table is simply the top of the zone of saturation, and the water table can move. Because if you were, say we dig a well and you're taking some of this water out, then imagine if you have a cup of water and your well would be a straw. If you start to drink the water, then the water level will move down. That means the zone of saturation is now smaller, which means the water table would move down. Because the water table is simply wherever the zone of saturation ends. It's just the top of it. So if you use more water or you add more water, then that means your water table will either go up or it will go down. Above the zone of saturation is what we call the zone of aeration. So the zone of aeration, think of air. So in the zone of saturation, all the little spaces between the dirt and rock is filled with water. In the zone of aeration, all the spaces between the dirt and rock is going to be filled with pockets of air. Now, this brings up a point that is important for you all to think about. When you look at groundwater, this is not a pool of water where a little fish could go swimming in. That's typically what people picture just because of the way they draw our diagrams. This is actually filled up with sand, dirt, and rock. Nothing could swim through there, okay? Imagine if you have a cup filled up with sand. You could pour water in the sand and sand would fill in all the little spaces. That is what the zone of saturation looks like. That is what your groundwater comes from. It's just the area where water is filling up the little holes of sand. It's not a big pool of water underground that you could swim in. That is something completely different. When we're looking at how water is filling up those little gaps I'm talking about, that is what we're talking about is a pore. When you look at a pore, just like pores in your skins or little holes or little openings, that is what a pore in the ground is. It's like little holes or little gaps. And so if something is porous, that means that it has many holes or many little gaps in between it. So if you have a cup of sand, it's going to have a lot of little holes in it, or even clay, which I'll show you later. It has lots of little teeny, tiny little holes that fill it up, and so it is a very porous material. So porosity and permeability. These are two very important vocabulary words that you need to understand. And this is what's going to determine how water is able to move into the ground and whether or not water is going to be stored in the ground. So porosity and permeability are two opposite things. If something is very porous, it can store water. So when you think of porosity, you need to think of storing. Okay, that's your key word. So if something is porous, it's like a sponge. Now, if something is porous, it has very small pores, very small pores. That's because the little holes in the ground are so teeny tiny that water fills them up, but it's not able to move through them. Think about if I had a little teeny tiny tunnel for you to crawl through. Say the funnel or the tunnel was about 2 feet high and about 1 foot wide across. That would be very hard for you to crawl through. You might get stuck. But if I had a large hallway for you to go through, you'd be able to get through that no problem. Well, if something is porous, the teeny tiny pores in it are going to be like that little tunnel. Water is not going to be able to move through easily because it's so small, and so sometimes that water gets stuck. If something is permeable, that means it has very large holes or very large gaps in it. Something like if you have a cup full of gravel and water can easily move through them. So this would be comparable to you walking through a hallway. It's very wide, it's very open, so you can just easily and very quickly move through. So porosity stores. Permeability is water's ability to move. So porosity stores, permeability is the ability to move through. And you just need to make sure you know those two vocab words and that you can tell the difference between them. This is just a little link that you can click on down here to show you the difference in permeability and porosity. If something is very porous and you pour water into it, the water just stores and holds it. If it's very permeable, then water instantly just flows straight through and out to the bottom. But that's a little video just showing you how that works. So in one of our previous units, we learned about soil texture. And if you remember, we said there are 3 main textures, and these textures are different particle size. So clay was the smallest particle, silt was in the middle, and sand was the largest. Well, like I was explaining on the previous slide, when you have a little tiny tunnel that you would have to crawl through, you'd probably get stuck and you'd move very slowly. Well, that's what clay is doing. Clay is the smallest type of texture that we have, and because it's the smallest texture, it makes lots of really teeny tiny gaps that water can't move through easily. So instead, the water gets stuck and the water is stored. Sand, on the other hand, has the largest pore spaces. And because these gaps are very large, water can easily move straight through, and so it's very permeable. So if something is permeable, that means porosity is down because they are opposite. If it's porous, then permeability goes down. So the smaller the texture, the more porous it is, meaning the more it can store. The larger the texture, the larger the gaps it has, so the water can easily flow through it, and that is permeable. So permeability is water's ability to flow through. It can flow through easiest with the larger pore spaces made by the largest textures. Porosity is water being stored, and it's going to occur in things that have the smallest pore spaces, which is made by the smallest texture, which is clay. So make sure you can keep those things straight in your head. You may need to write out a little chart or something to help you remember them. So what is an aquifer? Well, you've probably heard about these in middle school, but an aquifer is simply an underground storage area of rock. So if something is an aquifer, it's got to have permeable rock that water can move through, and then it will get stopped by a very porous layer down at the bottom, because that means water can't flow through it anymore. And then again, we have our saturated zone or zone of saturation. You have the water table, and then above it is the zone of aeration, which some people call the unsaturated zone. So same thing. Aquifers are very important because they store our water. And if you remember what we looked at earlier, 50% of the water that we use comes from groundwater. So it's good that the ground can store water so that we can use it. Aquifers form very slowly. So if you take hour-long showers and you use up all the water from an aquifer, it's going to take a long time for that water to get put back in the aquifer for you to be able to use it again. So don't waste your water. Also, that wastes a lot of money because water can be expensive, and you'll learn that when you start paying utilities. But anyway, back to science. To be an aquifer, the rock must be both permeable and porous. And that's because permeable, the water has to be able to move into the rock, and then porous, it's got to be able to store some of it. So it's going to be a mixture of your different textures. Aquifers are created and separated by impermeable rock. So that's what we're looking at over here. You have the water that has gone down into the zone of saturation. Here is where you have a layer of impermeable rock. That's what the bedrock is. It stops the water from continuing to move, and that's what allows it to pile up in that one aquifer. So when we talk about aquifers, I like to kind of see what people are imagining in their head. Some people view your aquifers like this. And again, they're probably thinking that a little fishy could go and swim through that water. Some people may think of an aquifer looking like this, just a very large gap going all across the bottom. And then some people may think of it looking like this. Both of these are pretty accurate. You can have many different aquifers all in one area. Those aquifers can be different levels and different sizes. Or you can have a city with just one long aquifer below it. It could be that way. Now, the thing to remember, again, a little fish cannot swim through an aquifer, okay? So this one down here that you're looking at, it does have a lot of gaps because it's filled with dirt and sand. This is just to show you that when you are looking at the zone of saturation down here, even the pictures show it just colored in blue, this is more accurate. You've got the little grains of sand, little pebbles and whatnot, and it just, when it's filled with water, that means all the spaces are filled. The zone of aeration, those little air spaces are filled with air rather than the water. So just to give you a better image of what wells look like. So again, the aquifers are the same. They could look like this, or they could have the many different ones. So if you could live, you could all be on the same neighborhood, the same block, and all have 3 different aquifers. So this person could have aquifer all their own, and this person could take hour-long showers and use up all the water, so that way this person has no water. So be mindful who your neighbors are. Brain break. This is a fun one, so I hope you end up doing it. So if you hold the peace sign up on your hand, so if this is your hand, the peace sign, 2 fingers, and then on the other hand, you do the little OK symbol. So you put your thumb and pointer together and hold the other 3 fingers up. And then you switch. And then on your other hand, you do peace and OK. And then switch to the peace sign. And then switch back to the OK sign. So if you can switch back and forth, it's very, very difficult. Sometimes it might make you put the wrong finger up. But it is a fun brain break. And you can attempt to do that with your friends or parents later. But it's a very challenging one. But let's keep going. A confined aquifer. This is simply an aquifer that is surrounded by impermeable rock. remember, something's permeable. Permeability is water's ability to move through a surface. So if it's impermeable, that means water cannot move through it. So if you're looking at this aquifer down here, it can only get into it from the top. This layer of clay is impermeable, and the reason that clay is impermeable is because it has very small it's very small texture, so it has very small pores. So it is so porous, water can't move through it. And then it has a solid rock down at the bottom, so that's the other layer of impermeable material. Up here, this is an unconfined aquifer because it has nothing that's impermeable above it. So if you were to build a house here, then I want you to think, which aquifer would be better for you to dig your well into? So you say you move out here because you want to get away from everybody and move out in the country where you're alone and you don't have the coronavirus to worry about. Then are you going to dig your well into this unconfined aquifer, or are you going to dig it into the confined aquifer? Now, some people say, oh, I dig into the unconfined aquifer because then when it rains, any of the rain that hits the land over here can all go into my aquifer, and so my aquifer will stay full of water. Other people say, well, I would dig it here even though it can't get filled up as fast. And this is probably the best one for you to do because the water that's going to go into here can only come from this area. Now, if you live in the country, you're probably going to have some cows. Okay, here's my cow. Moo. Okay, and what do cows do? They poop. And so when it rains, all that poop water is going to go down into your unconfined aquifer. So unconfined aquifers are typically more dirty than your confined aquifers are. So that's why it's better for you to dig your well, or cleaner for you to dig your well into your confined aquifer, because that is a protective layer blocking you from all of the pollution, such as your cow's poop up above. Okay, let's look at our next slide, a spring. So a spring is not just a season, but it is when you have groundwater that can naturally come up to the surface. This means you didn't have to pump it out, you didn't have to get a well, it just naturally was forced up. Now the way that the NCFE likes to word this is it is forced up laterally. If you're going laterally, then you're going up and down. So laterally, it just means it goes up. And the other way these springs can form is like this image down here, where your groundwater naturally intersects the surface. This happens a lot with mountains or areas that have very hilly topography. So here you can see the ground goes and then it dips down. And when it dips down, it dips into that zone of saturation, causing that water just to create a little pool that looks like this on the surface. And that would be called a spring. Typically, your springs are very clean because as water moves through the ground, it cleans it. And so groundwater is always moving. And as that groundwater moves, it cleans the water. I still wouldn't drink it, but if you're ever, surviving in the wilderness, springs are typically the cleanest place to drink water, or moving water would be the best place to go. Okie doke. Now we're going to look at an artesian well or an artesian spring. This, again, springs are when water is naturally forced to the top. This is a spring that water is being forced to the top because the water level is higher than the water table is higher than the well itself. So imagine if I have a cup, a cup that's filled with water, and I get a straw and I stick the straw in the middle of the cup. Well, if my water level is up to here, then that's going to force water to come out of the straw. But if the water level dips down below where the straw is down here, no water will come out of the straw. Well, that's what's going on over here. If the water table is higher than the well itself, then it will force water to come out of the well. But if the water level dips down below the well, then there's no pressure to force water out. Another type of spring you can have is what we call a hot spring. That would be like Old Faithful, where the pressure of the steam of water will force water out. And that is also considered a spring. So how do we get our water from the ground? Well, we use a well. And a well is simply a hole that is dug into the zone of saturation. and then we can pump the water out of it. We are next going to look at pollution and how our groundwater can get polluted. One of the main ways that groundwater can get polluted is from people creating what we call a cone of depression. Now think about if you are feeling depressed, you are feeling low. So when you think of depression, you can think of a low-lying area. A cone of depression is created because people are overusing a well. So that means they are using way too much water. And so they're overusing that well, and it's making the water level become very low. Now, if you've ever had a slushie or like a milkshake, then sometimes you can start drinking from that milkshake or that slushie, and then all of a sudden you get to a point where you can't drink anymore because nothing's coming up the straw, and you have to pick the straw up and move it over and start drinking from that area. And the reason that happens is because your milkshake or your slushie, it's not very fluid. It's too thick, and so therefore the liquid doesn't just flow over to your straw, so sometimes you have to move the straw to it. So with your cone of depression, kind of keep that in mind. You're using way too much water, and so the area over here of your water is becoming very low. Now water will move through the ground to fill in that gap, but groundwater, it moves, but it moves slowly. And because the water is slowly going to move back towards that lowest point that you've created, it will create this lower area that we call a cone of depression. And then on the next slide, I'm going to show you why this cone of depression can be a problem. But again, cone of depressions are created because we have overused water. Now, pretend this is your house, okay? And so you dig a well, and you dig your well right here. If your groundwater is moving this way, then that's perfectly fine. Everything is good. Now, once you move into the house, say you start using a lot of water, you keep running the dishwasher, and you're running large loads of clothes all the time because you never reuse your towels and your showers are forever long. You've overused your water, and now you've created a cone of depression. So instead of all the water moving this way, like it used to, now some of the water is going to move this way, because water always goes from the higher to the lower point. So if this cone of depression is now your new lowest point, then water is going to move over from this different direction. Now that may not sound like a big deal, but look at what's right here. This is a dump, meaning trash. So when it rains, all of this dirty water is going to go into the ground, and it used to not go into your well because your water flowed from the opposite direction. But now with your cone of depression, your water has changed directions, and now all this dirty water is flowing into your well, and then you are drinking that. So that's why a cone of depression can be an issue. It changes the flow of water, or it changes the direction the water is flowing, and then that can move pollution into your water, and that can obviously be a big issue. Here's another brain break that's kind of cool to do, but you have to have another person. If you get your hands and you hold them together like this little fella up here is doing, and then you fold your arms up so they're twisted like this little lady's doing, and then you get somebody to point to different fingers but not touch your hand. Just point above it, and you try to wiggle that finger. The fact that your hands are twisted confuses your brain, and it can be very challenging to do. So that's a fun brain break to try if you have anybody with you that can point to your hand. But again, you can't touch the finger, or that gives your brain a signal. So that's just cool. Now let's look at just a couple more things. Some other things besides a cone of depression that can lead to pollution are things such as gas, oil, and sewage and fertilizer that can get into the ground. So we can get fertilizer and stuff from farms or pesticides, and then we can get the gas and oil from cars that leak, or we can have sewage. At one point, sewage was actually just pumped into different bodies of water and not cleaned beforehand. Now we try to clean it, but sometimes that doesn't always happen. We'll look at that at a different point. And this is our last problem with our groundwater, is saltwater intrusion. So an intruder is someone that is not welcome into your house that comes anyway. So saltwater intrusion is when saltwater gets into a freshwater aquifer and it's not welcome, it's not wanted there, because we can't drink saltwater. And so how this happens is you have water that is always flowing. And remember, water goes from areas high to low. So naturally, the ocean is the lowest point. That's why we call it sea level. And all water drains there because it is the lowest point in that area. So your groundwater is naturally flowing towards the ocean. But if you live in this area and you dig a well, and again, you create a cone of depression from overusing it, you have now changed the lowest point. And instead of the lowest point being the sea, the lowest point is now your cone of depression. So water is flowing in different directions, and it will actually pull in this salt water and then cause you to have salt water in your what used to be a freshwater aquifer, and that's what causes a big issue because you no longer can drink it. So again, you got to understand why cone of depression can be an issue, just with that change in the direction groundwater moves. And that's a bigger issue because it's going to move your salt water into that area. So let's just make sure that's the last slide. Yes. So that is all for this part. Make sure you know that vocab. And if you have any questions, go back and rewatch part of it. Or maybe I didn't explain it well enough for you. You can Google it. You can look up things on YouTube to further look at videos or explanations of these cones of depression and things like that. But we'll go ahead and end this video for now.